Hi, I'm Cole, and this is my model of the Earth looking down from space. And I'm sorry about the white stuff; it was hard. But this is what it looks like looking down from space, and this is like the right placement. And then some reflection questions to answer on it is oh, um, the Earth looks like my model because it has shows the continents and like the ocean looking and round and shaped like it. It's but it's not like completely round. It's 3 dimensional. It's a sphere, but looking down from it from space, it looks like it's just round and not spherical, but it's actually spherical. And the second one is the experiences that led me to think this are that one, if the Earth was not spherical, then if the Earth was not spherical and it was flat, then the stars and the sun wouldn't move. It will appear to be moving, and and the Earth, because of the aerodynamics and some other factors, it wouldn't spin properly. And also, um, if you see like a ship sailing over the horizon line, it appears to be sinking, but it's just going over a slight curvature of the Earth. How would you describe the model? So my model, it's like looking down from space, and like this, so it's showing like North America, South America, Europe and Asia, Africa, and Australia. Antarctica is not in here; it's further down. Um, so my model's a model of the Earth, and it's kind of showing like how it would possibly look from certain perspectives of space. Depends where you're looking from in space. But this is one place where you could see like mainly most of it. And then the next question is, why might we use models in science? We use models in science to like get a visual perspective of what something looks like, so we can better understand it. And scientists make models a lot because showing us like how what the thing looks like and like how it's formed, such as like a globe. It's a model of the Earth. And the next one is, what are some examples of models? I already partly answered that. Another thing could be like a map, or possibly like a diagram of a human body, or um, many other things, kind of like a blueprint. That's kind of like, or like if the like SketchUp, like a little sketch of something could be a model of whatever. And then the next questions are um, the Earth and what it looks like. So this is the Earth from a perspective in space, and it looks like this. This is how the continents are organized. But Antarctica is down here, but it's low, so you couldn't see it. And then this is like the background of the Milky Way in space. Well, it depends on where you're looking from in space too. Like from some points, you could probably see the moon, but like now the moon's behind the Earth, so it's kind of blocking it. And we're looking outward, so you don't see like the sun or Mercury or any of those other planets. The next one is the point of view in the drawing. The point of view of the drawing is from space, look like far back in space, looking at the Earth. And another thing about it is that the Earth is not perfectly round because one, it's around the equator. When it's spinning, it stretches out because of a force, and that makes it a tiny bit wider than it is the width of it a little bit longer than the length. But it's so minor that you don't really notice. The next one is the limitations of your model. Well, this is kind of like the limitations. Like I couldn't so as you can kind of see, like what the limitations were and all of that. And then the next question is, from what point of view did you draw your model? For example, did you imagine you were in a plane high above the Earth, viewing it from space, or looking down through your front door, or something else? So I viewed it from space. Like, let's say you like in a rocket ship or something flying into space, and like you took a picture, it'd be from that point of view. The the Earth looks like my model because one, it is round or spherical, and it's like it has oceans, and as you can see the oceans. One thing that's a tiny bit different is the continents are probably a little bigger and a tiny bit differently spaced, but mainly this is the organization of the continents, and it looks like this because, like, looking down from the planets, it looks kind of green, like more so green. Yeah, and that's how it shows. You would kind of see it from space. Not exactly, but more so green than like anything else. And the the experiences that led me to making this, I would describe my model by kind of saying that it is an visual image looking from space onto the Earth, and seeing which shows the organization of the continents, and shows how they look and about what color they are. How might we use models in science? I already did that one. And what does the scale of a drawing mean? The scale of a drawing means like maybe like kind of like how big it is. Like, let's say like 1 centimeter equals like 10,000 miles. So that's kind of like the scale. So you'd measure like how many like centimeters it is across, and then you'd multiply that by 10,000 to get the scale, and that would be the scale. How does the size of the drawing of the Earth compare with the actual size? This drawing that you can see is nowhere near the actual size of the Earth. The Earth is like billions of times bigger, probably even more than that. The Earth is really humongous, and like it's much bigger than like anyone else. And yeah. And the next one is how does the point of view of a drawing affect the way the object looks? So it can affect the way, like if you were looking from behind, you would probably see some of the different continents. But the way I showed it was just so you could see all the continents. And maybe if you're looking down on it, you could probably better see North America. And if you're looking like from the at the bottom of the Earth, from like a point of view like a worm's eye view, you'd probably see Antarctica much like clearer. And the next one is that was the last one. Thank you for watching.